Here we go. NVIDIA Virtual Reality plus end-user computing. So again, here my name is Thomas Poppelgaard and proud member of NVIDIA Virtual GPU Community Advisor. So it's kind of a session very NVIDIA focused. Let me just see if I can remove these faces. You guys are beautiful. There we go. I just want to see my screen. Okay. And you see my screen, right? Confirmed?
Yep, all good, Sir Thomas.
Okay. Thank you so much.
Keep on rolling.
All righty then. Yes, sir. Okay, let's jump right into trends. So virtual reality. So a lot of things are happening. I know this is 2019, 2020, but you know, we could just wrap in 2020 as COVID. Funny bad joke. 2020, 19, 2020, 21, empowered edges, digital immersive experiences is evolving tremendously and getting more and more adopted, and especially now because of also COVID-19, it makes sense to be able to work intelligent by having headset devices, head-mounted devices, and being able to work with that. And that is stuff is evolving very a lot, especially around the empowered edge and technology, and thinking will shift to a point where the experience will connect people with hundreds of edge devices. That stuff is evolving now. We got HoloLens 2 and VR device getting super cheap, and more getting adopted now. So the companies is adopting that, making it able to work virtually. So of course COVID is as well helping with that. So Gartner predicting 2019 by 2021, in 2 years, 70% will be experiencing with immersive technologies for consumer and enterprise use. And again, based there's a lot of rumors with Apple actually making an AR device that looks amazing. There are some patents just released a couple of days ago. I think that's going to be the big jump when Apple do that. But right now, again, the devices companies I'm looking at are VR devices and augmented reality devices such as HoloLens that are the majority of the enterprise space. Let's look at some of what are the typical problems to solve on the current state of technology. So let's just do a 101. So we got however typical for these customers that are exploring VR, virtual reality. Virtual reality is you need a high-end workstation where you need beefy GPUs and that. You also need an employee who has the VR skill sets. So it means to be able to work with this. And then you actually have complex content you need to prepare. Some customers do this in 2D, and then they go into VR, and then they work an immersive experience, and that's where you see the headset to the left, and a nice bottle of wine when you are done with working. So funny side, sorry. Well, anyways, what I recommend is typically is also going and making a use case for customers where they either go in and see what do they need. Do they need for viewing? So this is where mobile VR extremely cost effective, like universities, hospitals, students, right? Low cost, driving that. And then we have the level entry designer, which is the mobile compute, such as Oculus Quest and HTC. They have these, all-in-one compute, what they call compute on the headset, with the 6 UF, so 6 UF 2 controllers, where you can move around with that. And then you have the HTC headset to the right with this tethered VR, where you are connected to a physical workstation with beefy GPUs and multi GPUs, and then you work with huge data sets. So what do you need to do with virtual reality for tethered VR? You have the typical headsets, you have controllers and a PC with a GPU. And if you want to have more fine-tuned, then also people have base stations that does the tracking, and then you build up a room and you're working that. So that's the traditional space. Now the problem about this having this tethered VR is that you have cables, a lot of cables. It is very difficult to move around. And again, we have this intellectual properties with these workstations where the data is on there, and it's very advanced. Now the mobile VR comes in and replace that, but where people are then getting customized an application. But the problem is if you have millions of polygons, that stuff can't run on the mobile VR, but it can run on the tethered VR. And this is where there's limited compute. So there's clearly a gap. And this is actually where where I'm going to explore what NVIDIA is developing. So the design elements of a VR experience is you go in, typically have a physical environment, virtual content, and user interaction, and then you also have, many cases, spatial sound and collaboration where you work with that. So typically, this is an Autodesk workflow where you work with from different Autodesk applications, from Revit to 3ds Max, going to Unity, and then apply VR interactions, and then you actually have the data there. It's the steps by doing this is actually quite advanced. So how can we overcome this and make it much more simplified with a press of a button? So we have typical end user computing space where on the left we see a workstation connecting to VDI, physical or virtual, and then typical solution with this is actually you take your VR content now on these VDIs to the left, and again you can bare metal or virtual VDI for this, and then you connect in with a VR streaming solution where you are streaming the compute to a headset where it's a mobile headset. So we're talking about the super high-end compute now streamed to a VR headset. So you're able to both work on your VDI by normal, and then you can actually connect with a streaming client with a mobile VR headset. And this is the NVIDIA Cloud XR. So NVIDIA Cloud XR are released now at GCC 2020. There's an SDK you can sign up for now. It used to be a limited program. Now you can sign up for it. Anybody can do that and justify why you're doing it. So it's a high fidelity AR. We're releasing VR solution to any device. And I'm only going to focus on the VR part. So you can also do actually augmented reality, where you can actually stream content to a phone. But we are only looking at the virtual reality, which is the all full immersive headset. It's scalability with Quadro WDS GPU, and you can also use Quadro RTX GPUs, so the real-time ray tracing GPUs, and use any open VR application. You don't have to develop anything. That actually just works out of the box, and then you just go in and sign up. And Greg Jones will then enable you from NVIDIA. So high level, what is this project vision? So you're taking content and you're actually putting the content on cloud servers. Again, this can be end-user computing environments, and then through internet or LAN, WAN, 3G, 4G, 5G networks. And then you connect actually basically on any device from VR to AR. That is the high goal. Let's look at what the requirements are of this solution here. So first, the first step is actually to have a cloud or to look at edge. And now if you do cloud, there's more parameters. So of course, edge is, you probably have more control of the network. So everything depends, but you actually have possible doing both. Step two, of course, is edge, then there can be LAN, but again, it can also be Wi-Fi, 5G networks, and internet. All these things really need to be controlled. So those are the properties, and then you have a client, the last part where you install an NVIDIA Cloud XR client. So some of the GPUs that supports this solution and is the recommended choice, but because more the high end, the really, really high end is having either one or several, many of these RTX GPUs with SLI, and then you are doing huge processing, not just 48 gigabyte, it can be, hundreds of gigabytes of memory where you're doing that. Some customers actually, having those kind of requirements. Next step is also to actually virtualize the GPUs, because these GPUs can be virtualized with NVIDIA vGPU. But if you do need these humongous frame buffers, you can connect them with NVLink. Now, if you do less workloads, you don't need so intensive, and you don't need those intensive ray tracing. The NVIDIA V100 is a choice, the P100. You can also use the T4, the low power GPU from NVIDIA to do this. And you actually, if you have a good network to the cloud, then it's also possible to do it actually from Azure or GCP or even AWS, because the T4 is actually available on all these platforms. And Azure T4 is very, very new. It's not open up yet for that, but NVIDIA has talked about the T4 is coming to Azure on Twitter. They have, so it's not something I'm breaking in NDA or anything like that. But if you want to try it at your phone on cloud, it's a Google GCP that you can do that. Let's jump on to the next step. So requirement for the headsets, the recommended choice as it is right now, default out supported, is the HTC Vive Focus, which is the white one, the Android client. So there's an Android client. You can also build your own SDK. So if you have like own customized VR headset, you can actually build your own client. And then you have the other headsets where you have Windows. So these can be HTC's, Vive, or others for that. What kind of bandwidth do you then need? So the client where you connect in for the requirement, it is recommended, of course, also to have the end device with the NVIDIA GPU in the low end that does the decoding. But yeah, you can again also use mobile VR, as I just stated with the Android. You see the all in one. The one down below in the Windows, of course, you need a Windows PC to do the decoding on that. But the bandwidth you use is up to 50 megabyte per stream and minimum 20 millisecond latency and minimum noise. Yeah. So, and that's when you connect to the data center. So it's extremely important when you do, of course, internet, then you really need to have really, really good monitoring on those parts to be able to deliver those things. But I would say it's actually technically possible, you know, depending on where you are, who you are, and where you're connected to, why it's possible technically. The encoders, you can do bare metal operating system GPU for this. You can also virtualize it with a hypervisor. VMware, you can use Citrix Sensor, or actually HV. VMware actually has this strategy. They created just a white paper around how you do that and how many users you can have on by virtualizing it. So that's extremely interesting. VMware is exploring that. Now, the good thing about actually, if you put everything together and then look at what can I do with NVIDIA Cloud XR, you can actually have multiple users connecting. So, you know, taking a physical GPU and cut it up to multiple pieces and actually reducing costs. You can do that and you can scale it out. And it supports NVIDIA vGPU. And it's also possible to use it all from, you know, 3G to LAN to cloud scenarios and do from all to mobile and tethered networks. The Cloud XR reference design, what I want to look at, because again, now we just covered what is possible. It's actually just, so again, a piece of client you install in a physical machine, and the NVIDIA Cloud XR, and then you have an end device where you then stream. So it's a sender receiver concept, really simple. So that's why I'm saying you can actually take your existing EUC platform with, you know, if you have these high-end GPUs, then you could actually enable it with Cloud XR extremely easy, which is really cool. Now, I just want to go through and look at what your reference design from Hewlett-Packard Enterprise and NVIDIA has. So this is something that is not, you know, that they don't push out, but I work a lot with this platform, which is the Edgeline. It's an EL4000, a 1U server where you actually have 4 physical servers in one. Now, the beautiful thing about this server is extremely low watt, 800 watt, and you can put in 4 T-Force and GPUs in this. And having this brand new, actually, this next generation moonshot just got announced, actually not so long time ago. So I just want to make a very big thing about this. So this is first 5 gigahertz CPU, actually in servers, and it's in the moonshot. And what I would then recommend is turning off the onboard GPU and then use of course, the NVIDIA T4 GPU for this, which you can use for more like low-end Cloud XR workloads. And that's what I'll be using with this beautiful GPU here. So the nice thing about this design is actually we have 4 physical users on this, with each having its own individual CPU, 16 cores, 5 gigahertz, 128 gigabyte memory per user, and up to 16 terabyte NVMe, and a T4 for user. Amazing. Now you can also virtualize this. Next step would also be, if you want to do more high-end from HP, you have the EL8000, not 80,000, but 8,000, which is a very interesting form factor server here, where you are capable of putting in RTX GPUs into this server here. So here you actually forget the full CPUs, like proper, from typical servers. Actually, this service, even you could put it into a plane and walk around with it and take your own data center. So it's a really interesting concept. This service here is very popular for telcos. They're looking at that. And again, here you can put in for users, for physical users without virtualizing it. And of course, you can virtualize it. So here, first, with the low end is NVIDIA T4 your GPUs you have, where you have 4 users on it, or you can put in multiple RTX GPUs in this setup. So quite an interesting concept. And then you have the more traditional servers, which is the generation 10 from Dell, HPE DL380 Gen 10. Sorry. And in this architecture, you know, typical one server, you put in multiple GPUs. So here it's up to seven T4s. And of course, here it makes sense to virtualize it using PGPU and having 7 VMs with each GPU. You can even get it further and virtualize it with the vGPU with the Cloud XR and having more users. Now, the problem here is CPU, right? You get bounded with CPU. But you can then also put in the more high-end GPUs from NVIDIA with the real-time ray tracing with the 6,000 and 8,000. So I went through the reference architecture, and I think it's really interesting what you can do with HPE. And here I just want to show you guys. So this is actually with a customer I work with where they have Cloud XR. Now I can show the application they have because of intellectual property, but here we're just having actually the most high-end game they tried, which is the most insane graphics. And we are pushing here an RTX, I think it's 6,000 here, and using 43%. And you can use it using steady 54 megabytes, so up to 50 megabytes steady stream per session. And here they're loading it. It's insane because here we're actually using an HTC Vive Focus, which is a mobile VR, and we are streaming from a workstation, a physical workstation, to the mobile VR headsets. It's insane when you try it. You know, this is the next generation streaming virtual, taking next step. It's removing the boundaries of VR. So it's amazing. Yeah, I put together some resources. You can read more about it. You want to sign up and try it out. You sign up for this Cloud XR SDK, go to the blog. They also have a nice presentation. And I really highly recommend the VMware white paper running augmented reality and virtual reality applications of VMware vSphere, where Duncan and Matt from VMware, they go through a very comprehensive, you know, how many users they can have on, and they try out from RTX GPUs to T4 GPUs. And also Ben, one of the other NGCA guys who has a Grid Factory, has been part of this work. And I know Johan has also been part of this work. So amazing what they've done here. I really loved what they are sharing there. So that's good and nice to have the first reference guide out there. And yeah, that was actually it. So again, thank you for joining the session. If you have any questions about Cloud XR, please feel welcome to reach out to me. Thank you so much.